Hello everyone, my name is Sahil Agarwal, Assistant Professor, Department of Information Technology. And today we are going to discuss transmission impairment. It's a topic of computer networks, and let's start with the introduction first. So, what is transmission impairment? So, if we talk about impairment, a thing which is not perfect is called impairment. And when we talk about transmission, means there is a signal involved which carries the data, and there is a some imperfection involved in the signal, that is called transmission impairment. So, the imperfection causes signal impairment. We can say that this means that the signal at the beginning of the medium is not same as the receiver end. So there are many causes of that. There are mainly three causes of transmission impairment, which are attenuation, distortion, and noise. First of all, we will study about attenuation. So what is attenuation? Attenuation generally means a loss of energy. Means when a signal travels from one side to another, or we can say that when a signal travels from sender to receiver, if there is a higher distance from one side to another, so at the certain distance, signal loss is strength, or we can say that loss is energy. That's why there is a attenuation in the signal. To overcome this particular part, we need amplifiers and repeaters to uh, increase the signal strength where it were in the beginning. So, if we can say if we see the example, there is an original signal. After attenuation, it loses an energy. As you can say, just a second. As we can see, this particular signal is lost its strength. But by the help of amplifier, we can regain its value again. That is the main work of amplifier. So, when we talk about any kind of strength, we talk about in decibel. Decibel is a measure unit in where we find the strength of, or where we find the unit of any measurement. So, decibel is 10 log base 10 P2 by P1, where P2 is output signal and P1 is input signal. By this formula, we can find the energy unit of loss or attenuation. But if the value is given in volt, then the formula will be in decibel, as we have discussed, that will be 20 log base 10 V2 by V1, where V2 is output volt and V1 is input one. So let's see one example of the same. Suppose a signal travels through a transmission medium and its power is reduced to one half. Means at the output side, at the receiver side, we get just half of the output, but we have intended at the beginning. This means that P2 is 1 by 2 P1. In this case, find out the attenuation. As we have discussed, the unit of attenuation or to count the loss of energy in unit is decibel. So the formula is 10 log base 10 P2 by P1. As it is talking about power, so this formula will apply. And there is one point is given that P2 is equal to 1 by 2 P1, or we can say that it is equals to 0.5 P1. So let's put the values. So the 10 log base 10 remain as it is. P2 at the place of P2 we can say write 0.5 P1. We have written that, and this is P1. The rest is 0.5. So we know that 10 log base 10 is 1, and 0.5 log base 10 is 0.3 minus 0.3. So we can say that it is minus 3 decibel. So now we will talk about distortion. So when a signal changes its shape while traveling is called distortion. So the main point is that distortion occurs in composite signals. And what is composite signals? When more than one signal carries data and combined together at the source side and sent as a single one signal from one side to another is called as composite signal. So each data has its own propagation speeds traveling through a medium. So what is the reason of sending the signal in composite way is that there is only one medium like this, and there are many users to send the signals. It can be any device or any user, and all the data needs to be carried at once. So we combine them, which is called composite signals. So there are different components, therefore arrive at different delays. So because of composite signal, there may be delays. But if there is a distortion, let me show you a diagram for this. This is the source center side where we have combined all these three signals together and made this composite signal. But during the transmission, some of the signal changes its shape like this. Like this. There is a difference in this. There is also a difference in this. It changes its phase. So after changing in signals may result in the distortion in a composite signal. So when we decode it in a particular signal, it will show the different result. So that is called impairment for this. Impairment due to distortion. So let's talk about noise then. So noise is a thing which we cannot avoid, or we cannot avoid 100%. So there may be many type of noise. It can be thermal, induced, crosstalk, or impulse. The main point is first of all we will talk about crosstalk. Suppose there is a signal of one device and there is another signal of another device. Suppose this signal is user 1, this signal of user 2. Suppose due to sudden impulse or sudden value change, the value of this user 1 touches the value of user 2. It means both signal are same now. Means the value of one user can be read by the value of user 2. This means one person can hear the value of another person. This is called crosstalk. Thermal, because of the heat of the wires or random noise of electron wire creates, which we cannot avoid but reduce it with the quality of wires. And next is induced signal. When we talk about motors and appliances, there are some noise induced with them. So when we receive through the signal through antenna, so we need to avoid those type of noises. Last is impulses. There is a sudden spike due to any voltage check or any fluctuation, which is called impulse. So all these are called noise, signal noise. So there is always involvement in the signal of noise. We can reduce it, but we cannot avoid it 100%. So there is a one example of this. This is a transmit signal, but due to noise, we can say that there is some more signal than this. So this is greater. This contains greater value than this transmitted one. So and the receiver end, we have to follow this particular part. So at the receiver end, we need to avoid or we need to reduce the noise to get the actual data. And we can say that transmit data and receive data is different. That is because of noise. And when there is a noise involved, there is always a impairment. We need to refine it, but we cannot achieve the 100% accuracy. So how can we find how much noise is there that we can tolerate in a particular signal? For that purpose, we find a SNR. SNR means signal to noise ratio, or we can say that average signal power upon average noise power is known as signal to noise ratio. But when we talk about the strength, as we discussed before, it is counted in decibel only. Decibel is a measurement of strength. So when we talk about how much power does signal to noise ratio have, so we need to find a SNR dB. So this is the formula of SNR dB, which is 10 log base 10 1 plus SNR. Let's talk about one example then. The power of a signal is 10 megawatt given and the power of the noise is 1 microwatt. What are the values of SNR and SNR dB? First of all, SNR is average signal power upon average noise power. Signal power is this and noise power is this. When we divide them, because it is micro, it is mega, so we get 10,000. I think there is certain differences. It should be mega. Now we will talk about SNR dB, which is 10 log base 10 I1 plus SNR. So SNR is this. I think there is a certain difference in this. Let me correct you first. This is only SNR. 10 log base 10 SNR. So when we talk about SNR dB, it will be equals to 10 log base 10 SNR. So though we have counted the value of SNR is 10,000, so 10 log base 10 10,000, which will be equal to 10 to the power 4 10 log base 10, which is equals to 40, as we can see that. So we can easily find the values of these SNR and SNR dB, which are very important for the examination purpose as well. So there is one more question: the values of SNR and SNR dB for a noiseless channel. Actually, when there is a noiseless channel, there is nothing like SNR and SNR dB. So when we talk about SNR, it means average signal power. So signal power is there. Average noise power is nothing there in noiseless channel, so it will be 0. So means SNR will be infinite. When we talk about the SNR dB, the formula is 10 log base 10 SNR. So we found that SNR is infinite. When we put the value of infinite in this particular part, we will always get infinite. So when there is a question of finding SNR and SNR data decibel for a noiseless channel, it will always be infinite. So that is all for today's lecture. Thank you everyone. These are the references that I have taken from. Thank you everyone.